Okay, welcome to ELM Prep Part 13. Welcome back if you're returning. This episode of craziness is dealing with square roots. A couple ways we indicate a square root is with this symbol, some value inside. The other way we represent this symbol is with a fractional exponent of 1/2. So both of these are equivalent. This is square root of x. This is square root of x. One way, let's say I had 10 here. Well, I'm dividing by 2, and understand that there's understood 2 out here on the porch. So this is 10 to the 1 divided by 2. So 10 to the 1 divided by 2. This is exponential division. Now when you're dealing with numbers, it's harder to see that concept, but it is exponential division. Letters are easy, numbers are hard. If I had the square root of x squared, remember I said there was a 2 out here. This is 2 divided by 2, or x to the 2 divided by 2 is another way of writing this. And 2 divided by 2 is just 1, which is equal to just x. So, exponential division. Divide this number by this number. Just like in regular division, your divisor sits on the outside. We talked a little bit about estimating square roots last time, and now we're talking a little bit about how we do a particular square root in terms of letters. Let's say I had the square root of a squared b cubed. Well, I've got 2 here and 3 here. 2, I'm dividing by 2. 2 divides evenly by 2, so I'm going to get one of them out. 2 divided by 2 is 1. Over here I have 3. Well, that doesn't divide evenly, so the question is, what do I do with it? What I do is I break that 3 up into 2, nice 2. 2 plus 1. 2 divided by 2 is 1, so I get one of the b's out. And this came out, but I have one of the b's left, so my answer has to include the b that did not come out. So I divide out odd ones. If I have an odd division, then somebody stays behind. Anything even comes out. This came all the way out. 2 of these come out. One of them remain behind. So, like I say, letters are easy. Let's say they gave us something like this. Well, I could break it up into the square root of x cubed over the square root of x squared. This is legal, to take 2 inside divisions and break them up into 2 separate ones. Sometimes it's helpful to do that. Sometimes it's helpful to just clean it up inside before doing that. Either way is valid. So I have 2 on the bottom, 3 on the top, so these 2 go away and 2 up here go away, leaving me with just 1 x up there. So I end up with the square root of x, and I only have one of them, so it doesn't divide evenly, it stays behind. Well, what if I have square root of x squared? I'll just make this x. And I have 3 of those, and I'm adding 2 square roots of x. I have 3 square roots of x plus 2 square roots of x, and maybe intuitively you see that, well, I have a total of 5 of the square root of x. This quantity and this quantity are the same quantity. So I have 3 of that quantity plus 2 of that quantity for a total of 5 of that quantity. Well, that seems pretty straightforward. Same way if we were to subtract them. 3 square root of x minus 2 square root of x. These quantities are the same. Therefore, I can do this subtraction. Notice that what I'm subtracting is the numbers out front. 3 take away 2, I'm left with 1 square root of x. I do not subtract the insides. Well, what happens if I have the square 3 square root of 5 plus 2 square root of 5? Okay. First thing I check, are these the same quantity? They're both square roots and they're both 5. So these quantities are the same. That being said, I can then add my outsides. I will then have 5 square root of 5. Okay. What if they do this a lot. We'll say they give us something like this. Square root of 9 plus square root of 27. Oh crap. Now what? Well, there's nothing I can do with the insides. I cannot add the insides. I cannot subtract the insides. I can only add or subtract the outsides. Well, I have 1 out here, but the problem is these are not the same, so I will not be able to add them, apples and oranges. But I look a little closer at this 27 and I realize that's really 3 times 9. Oh, well, and I realize that this, the square root of 9, is actually just 3 plus my 3 times 9. This part's a square. It's coming out as a 3. This guy gets left behind as a square root of 3. Well, again, I still do not have the same thing, so that's as far as I can go. I can bring out a common, but my insides are not the same. So I could reduce it out and bring out the square root, but I cannot add them. This is just 3. This is 3 square root of 3. So if they're not the same, I cannot add or subtract them. Let's do this. Well, initially it looks like there's nothing I can do here because they're different. But I recognize that this is 2 times 9, and I recognize that is a square, so I can bring it out as a 3. Now that's gone. Now I have 3 square root of 2 plus square root of 2. Now these are the same radicals. The roots are the same. They're both square roots. I can add them. There's 1 here plus 3 there for a total of 4 square root of 2. So sometimes I can play around with what's inside to make them equal to each other. That's probably one of the most common ones when you see them asking you to add or subtract radicals. You want to look what's going on inside. Let's say that I had the square root of 5 times 4 plus the square root of 5 times 9, which would have been a square root of 20 plus the square root of 45. Initially I say, they're not going. But when I break them up, I see, oh, that's a square. I can bring that out as a 2. And this is a square. I bring that out as a 3. And I'm left with radical 5 inside. So now I have radical 5 in common. And I have 3 there and 2 there for a total of 5 radical 5. Very common kind of problem when you're looking at adding and subtracting. So when they do an add or subtract of a radical, you want to automatically look at the insides and see if you can somehow bring part of it out. Okay, well, adding and subtracting radicals. That pretty well ate up our time. Hope you enjoyed the thing and it was a little bit informative. We'll talk a little more about radicals, multiplying and dividing radicals in our next episode. Come on back. Have some fun. Have a good day.